It's 8 a.m. in the center of Manhattan. And these men are on a mission. Today, they must raise over 45 tons of steel, 220 meters in the air, to complete the 48th floor of this monumental tower. They're in a race to get this skyscraper to its full height.
All right, Frankie, everything looks good, bud. Go ahead up.
When complete, One Bryant Park will tower 365 meters above Manhattan's streets, second only to the Empire State Building as the tallest skyscraper in New York City. To do that, they must build the structure 288 meters high and then top it off with a 78-meter spire, one of the largest spires ever erected in the city. But the building's biggest achievement will not be its height. One Bryant Park is said to be one of the greenest skyscrapers in the world. Its combined green features will be unprecedented. It's an ambitious plan to have so many energy-saving systems combined into one skyscraper. And it's the brainchild of this man. Architect Richard Cook's dream is to raise the most environmentally friendly skyscraper in the world.
As an architect, I think we must immediately radically change the way we build buildings and radically change the way we build cities. I hope that when people look at One Bryant Park, they think that it could be an icon of when we started thinking fundamentally differently about the environmental impact of a skyscraper.
Cook's vision, One Bryant Park, is out to tackle a big problem. Buildings account for nearly 40% of total U.S. energy consumption. Each of these buildings need energy for lights, elevators, phones, computers, faxes, air conditioners, and running water, round the clock. It's a problem that the Bank of America and the Durst Organization were ready to confront when they commissioned the revolutionary building.
We want to be seen as stewards of the environment. It was clear that we could actually build the most environmentally sound building, skyscraper, in the world.
The bank gave Richard Cook the opportunity he was looking for. Cook's vision, One Bryant Park, will combine multiple cutting-edge methods to save energy and resources. First, ventilation. A state-of-the-art system will take in air, clean it, circulate it through the tower, then expel it back out into the city. Next, recycled water. An advanced reclamation system will collect all rainwater that falls onto its roofs, storing it in large gray water tanks. The rainfall will be reused throughout the tower to help supply water systems for the skyscraper. Then, glass. A new crystalline facade will help keep the heat out, lowering dependence on interior lighting and air conditioning, saving on electricity. Cook's first challenge? Coming up with the initial design.
As an architect, you start with the blank canvas. It's what should this building look like? We're really interested in the pursuit of the perfect form, whatever it might be, at this location, at this place. So this board that we're looking at here are a whole series of sketches of ideas. And when I look at this, I can see pieces of the building that exist in its final form.
Building his vision is not an easy task. Not only is Cook raising the tallest energy-efficient building in New York, he has to build it in one of the toughest places in the world, Midtown Manhattan. Erecting a skyscraper in New York City creates extraordinary challenges. A especially at the corner of 42nd Street and 6th Avenue, one of the busiest intersections in the city. To start off, the crews must dig one of the deepest foundations in Midtown.
This is an incredible deep foundation. It's the full width of the site, so 200 feet long, 450 feet wide, and it's about 100 feet deep.
Over 198,000 cubic meters of earth had to be removed from the site. But the team faced a big problem. Blasting in Manhattan is forbidden.
Typically, blasting is the most efficient, quickest way to get through all that rock, but we have subway tunnels on 42nd Street and another subway line coming up and down 6th Avenue, which are right there and right there. And we can't really blast adjacent to that. There's also historic buildings all around the area, as well as a 50-story tower directly adjacent to us. Not really conducive to blasting.
So they had to do it the old-fashioned way, by digging.
You can't dynamite Manhattan, so it's all chiseled and machined out with large excavating machines.
All told, it took almost a year of excavation. By July 2005, the foundation was finally complete. Almost 2 years later, the building stands 48 stories high. That's over 200 meters above the streets. With 7 floors left to go, they're almost at the top. And work continues furiously. Today, they must lift almost 36 tons of material into the tower. With the help of a crane that sits almost 228 meters above the street. At the foot of the skyscraper, foremen prepare the loads. The crane operator is so high up, he can't see the loads hundreds of meters below. At these heights, the operator must lift each load blind, relying solely on the voices of his crew.
Stop at the scan button now. I've got 25 to my hand. Keep coming up 3, 2, 1. And coming into it.
The crane's biggest job is lifting the enormous steel beams to iron workers that continue to build the floors of the tower. But first, the crew must get them here. The beams arrive on large flatbed trucks.
This is just an average load. This is about 23 ton, in that range, give or take a couple hundred pounds.
But getting a truck like this through the city traffic can be a nightmare.
We come in like 5 in the morning for traffic reasons. Mike will call us and say, all right, come on up. So then we start coming up. But that's the biggest nightmare is getting here.
By midday, the traffic gets worse.
I need a long distance to make a turn now. Like there's no way I can make one of these turns down these streets. I'm gonna have to go down, cut over 3 lanes to make a left-hand turn down there. There's no room to park on these streets, so that's the issue.
Once the steel arrives, the men work quickly, raising about 20 tons of steel to the 48th floor. Although these look like average steel beams, they're actually a secret weapon in this building's green arsenal. To be one of the most environmentally efficient skyscrapers in the world, One Bryant Park will embody state-of-the-art green systems from surface to core. Architect Richard Cook's conception is about changing how commercial buildings are constructed.
The fundamental breakthrough wasn't to design a building and then see how green you can make it, but it was in the DNA of the project. It was, how do we fundamentally rethink the way we build a building?
Cook's team decreed that many of the materials used to build One Bryant Park must be sourced within an 800-kilometer radius of the site, cutting transportation costs and energy use. What's more, the most basic building materials of the tower are largely recycled. It's one way Cook's team saves energy on the building from the ground up. All of the steel used to build the skyscraper is at least 60% recycled materials. Every steel beam going into the building started here. This plant collects scrap metal. Then, steel workers melt it down, remove impurities, and adjust its chemistry.
Our steel, first of all, starts with scrap metal. We recycle scrap metal. Almost 95% of our raw material is nothing but recycled scrap metal. That's your old cars, old washing machines, old dishwashers. We shred it, we compact it, we sort it, and that becomes our basic starting point.
This molten liquid runs through the molds and transforms into steel beams. Then, machines roll them out onto cooling beds, most still glowing from the heat. Once cool, workers test them for strength and durability. From this steel mill, each beam eventually makes its journey to the One Bryant Park site in Manhattan. But steel is not the only sustainable element that leaves this plant. Even the waste of the steel mill helps create sustainable materials. Steel mills produce blast furnace slag, a waste byproduct of steel production that is usually just thrown away. But for the One Bryant Park site, this slag waste is reused. It's a key element of the building's concrete, making up 45% of the mix. This leads to a drop in the carbon emissions created during concrete production.
When we work at scale, when it's an enormous building, little changes make big differences. Change from regular cement to blast furnace slag save 56,000 tons of CO2 production. So the concept is work at a really big scale, make little changes, you make big difference.
All told, 52,000 cubic meters of this concrete slag mix will fortify the superstructure. Not only does the production of concrete slag emit less carbon, it also makes the concrete stronger. Building with green materials is challenging in itself, but the teams at One Bryant Park must also face all the construction hurdles of any new skyscraper, like the unforeseen forces of nature. At the site, the skies open. A torrential downpour, which would one day fuel the building's water reclamation system, now forces most of the construction to a screeching halt.
Between the driving rain, the wet decks, it's made it difficult to get people up here in a safe environment for them to continue the steel erection. All the steel erection and the perimeter work is done for the day.
But not everyone is deterred by the rain. To keep on schedule, work must continue. The team braves the elements, pouring concrete floors even in the downpour. Surprisingly, the rain doesn't affect the concrete's strength. The men must keep pace with the steel erection to finish the building on time. As the building rises, so does the pace of the